In Lab 4D, we'll take a look at the efficiency of a common house fan by comparing the power that it outputs on the air as it flows through to the power that it takes in to run. Briefly, this is a schematic of a fan blade, and this is a velocity triangle of air as it leaves the fan. The equation you'll be using is this power equation here, which states that the total power done in the air is the negative power inputted plus the power outputted. Because all flow into the fan we can assume is axial, our input power term will go to 0. So all you'll have to worry about is the output term. The output term is equal to the mass flow rate of the air as it leaves, which is just equal to this equation down here. The density of air times the axial velocity of the air out of the fan times the total area of the fan. The velocity of the fan blades themselves will be measured with a stroboscope, which you used in Lab 4C. And the velocity of the air in the radial direction as it leaves can be found from the velocity, the axial velocity of the air as it leaves, the angle of the blade, and the velocity of the blade. To measure the angular velocity of the fan blades, you'll again use the stroboscope that you used in Lab 4C. To measure the axial flow of the air as it leaves the fan, you'll use this flow meter. Simply open it up, turn it on with this button here, and place it in front of the fan at an average radius. You'll get a reading on here. To obtain the input power for the fan, plug this amp meter up in series with the fan. Plug the cord of the fan into this and plug this into the outlet. Switch the dial all the way to the far, which says A. That's amperage. Make sure it reads AC because your current is AC. That will give you your value for current. Assume 117 volts, which is standard for the United States. For all your geometry measurements, use this open fan blade. We'll give you the angle beta 2, but you have to measure the area of the fan as well as an average radius.